Hello everyone, welcome back to my YouTube channel, and today we are going to be talking about rolling resistance in tire grip. And this is a very important topic in regards to suspension design and tire selection. So let's get started. So we'll start with rolling resistance. How do we define rolling resistance? Rolling resistance is essentially can be defined as tendency of a tire to induce a force which resists the vehicle motion. So why does that happen? So let's see. Consider this a tire which rotates in clockwise direction, and when the tire rotates, obviously we see some kind of deformation which is not shown over here, but it would be like tire would flatten out a little bit over here, and which induces a stress. So obviously any material which goes under deformation will induce a stress. Stress is obviously defined as restoring force per unit area. So as the and tire is made of rubber, which is a viscoelastic material. So as the tire is deformed, you will see that the stress is generated. The stress will increase as the load is increased, will reach a maximum value and come back down. So this is basically the stress graph of the tire. So this is the stress graph of a loaded tire under ideal conditions, but it doesn't actually happen like that. The real stress graph is actually something like this, and it is a little bit offset from the center line. So what happens over here is because of tire being made out of rubber and rubber being the viscoelastic material, it has some kind of hysteresis properties attached to it. So basically, again, more on that later, but hysteresis can be defined as a material property in which strain lags behind stress. So show you more about it. So due to which, like when the tire is loaded, it gets deformed. So as the tire is loaded, the stress increases, reaches the maximum value. But when it falls back, when that particular point of tire, it moves back and goes into the unloading state, the tire doesn't recover the original shape immediately. Like it gains as the stress is applied for the same stress, the tire doesn't get back to its original shape, and that's why we say that strain lags behind stress in that particular manner. So when this happens, the stress is offset from the wheel center line, right? That induces a force F in the tire because of its viscoelastic properties. So essentially, there is a force acting F on that particular line, which is offset from the wheel center line at a distance of x. That again induces a torque which opposes the vehicle motion, and this is known as rolling resistance. So now we'll discuss more about hysteresis property. This is example graph of hysteresis of a viscoelastic material. So if you look at the big graph over here, what goes on is as we load the material with stress, it follows this pattern. It loads and goes to the highest point, then it comes back, and as it comes back, if you look at it, these 2 points, look at this line and the 2 points over here, one point over here which is high stress, and this one which is low stress. So basically, if you would see, the strain value for these 2 points is the same, but during loading the stress has a higher value as compared to the unloading curve. So basically, for the same strain value, you would have higher stress during loading and lower stress during unloading, and that's what we are seeing over here in this case. That's the reason why there's an offset over here. The stress induced in the tire is offset from the wheel center line. So that's why that's one of the properties due to which the stress induced in the tire is a little bit offset, and which leads to rolling resistance of the tire. So in ideal cases, we would want very low rolling resistance in a tire. And also one additional information, the all the area between this graph, this is the energy dissipated in form of heat. So if a tire, if you look at these two graphs, if a tire is having low hysteresis, then it would have small deviation between the loading and unloading graphs, and accordingly the stress value for the same strain during loading and unloading patterns, it won't be very different. Whereas in case of higher hysteresis graph, you would see that there's a larger gap between the stress values for the same strain. So essentially, how does it affect us? Like, what do we need from a tire? So essentially, we want the tire to have high durability and low rolling resistance. For rolling resistance, we would need it to be having a less of hysteresis value. But essentially, if it has a smaller area under the graph, then that would mean that it has less energy dissipated, which means lower hysteresis, and it's more efficient and more durable. On the other hand, with a bigger graph, bigger variation in its stress for the same strain in loading and unloading patterns, we would have more energy dissipated because of the area occupied by the graph. That means higher hysteresis and more grip. And why would we say it as more grip of a tire? So we know the grip can be defined as basically the coefficient of friction between the tire and the road, which can be applied both laterally and longitudinally. Or this can be applied longitudinally as well, but again, that viscoelastic property of the tire and hysteresis also creates the friction rolling resistance, right? So grip is essentially defined as this. So assume this to be a tire, like if you're looking at it from lateral perspective, this is tire and this is the road surface, like random road surface. So it will have peaks and valleys of its own. So as we know in Formula One, there are different tires, different compounds, hard compound, medium compound, and soft compound tires, right? So each of those tires, like hard compound, medium compound, and soft compound tires, these all have their operating window, a temperature operating window, and during which they give the maximum grip. That, and what do we mean by having most grip? That means that the adhesion of the tire on the road is maximum, and it also gives us optimal value of durability. So hard compound will have are usually low hysteresis tire, and soft compound being more grippy tires. But in the end, what do we want is, like, if we have more grip on a tire, essentially more power we can deliver on the road and the faster our car can run. Like if we don't have enough grip and we have a very powerful engine, we won't be able to deliver that power on the road and it won't be of any use. So hard compound, coming back to our point, the hard compound, medium compound, and soft compound tires have different windows, different temperature operating windows during which they give the maximum grip performances. And when we say grip, so essentially during those tire temperature values, the tire adheres more to the road and due to intramolecular bonding. So as we see, like this would be the shape of the tire and it would interlock better with the road surface, and hence it would give us better grip. So essentially a hard tire, back to our presentation, like hard tire would have low hysteresis and like it would dissipate less amount of energy. That means it would get hot after a longer period of time. On the other hand, a softer tire would have more hysteresis and would eventually generate more heat sooner and would get into that particular temperature window very early as compared to the hard compound tire. But on the other hand, it won't be that very durable to sustain for enough number of laps. But hard compound tire would be lasting longer lap period, and accordingly we have to choose the tire compound depending on the racetrack situation or what is the need or what type of track is it like a fast track or is it like where we have too many turns or whatever. So we have to decide, like, it does it have too many hairpins or it does it have long straights, or depending of all these factors and also on track temperatures as well, we have to decide what kind of tire compound we have to select. I hope the topic was clear, and if there are any doubts or questions, please let me know in the comment section below and I'll be happy to answer. And thank you so much for listening.